Well, thanks everyone. It's great to be here. It's my first time in Tokyo and I've really enjoyed my stay so far. So I'm going to talk to you about unit testing of Vuex store, and I'm going to go over 3 different approaches that you can use to unit test Vuex store. My name's Edd Yerburgh. I'm a software engineer at the BBC in London, and I'm the main author of Vue Test Utils. Testing. So you can find me on Twitter at Edd Yerburgh. So this talks about unit testing of Vuex store. So before I talk about unit testing of Vuex store, I just want to go over what a unit test is. So put simply, a unit test is some code that you can run that calls another part of your code and reports back on whether that code is behaving correctly. So imagine that we have a sum function that we export in a module that just sums the values of its input. And we wanted to test, to check that sum function is behaving correctly. So the way that you can write a unit test using a framework like Jest is that you define a test function. So with Jest test framework, the test function defines a test, and then in the actual function itself, you create an assertion using the expect function. You call expect with value, so here we're calling it with the return value of the sum of 1 and 3. And then expect exposes matcher functions that compare the value that expect was called with. So when we run this test, if the sum of 1 and 3 returns 4, then the test will pass. But if the sum of 1 and 3 doesn't return 4, then the assertion will fail and throw an error and the test will fail. So there's a few reasons why we would want to write unit tests. Firstly, unit tests verify that your code works. So this is really useful when you're refactoring old code or working on a part of the code base that you haven't worked on before. If you have lots of unit tests, you can run them and get quick feedback about whether that code is behaving correctly. Another benefit of unit tests is that they actually document your code. So a unit test documents your code, firstly in the spec name that you give it, but also the test itself defines exactly how a unit of your code behaves. And this can be really useful when you have a legacy app that's maybe the people who originally wrote part of the application no longer work there. You have to go into a part of the application and fix a bug or add a new feature. If you have unit tests there, then that documentation that they provide makes it a lot easier to do any refactoring. And also, unit tests enable workflows. So I'm thinking test-driven development in particular, which is a workflow where you write your test before you write any source code. So that's what a unit test is. And this talks about unit testing of Vuex store. So Vuex is a state management library and a pattern for managing state in Vue apps. So you have your state, which is used by components to render, and then your components can update the state by dispatching actions or committing mutations. And the store is this part of the Vuex flow. So in this talk, we're just going to look at how you write tests for the store, rather than how you would write tests for components that interact with the store. If you take a closer look at the store, it's made up of 4 main parts. You have actions, which are asynchronous functions that can commit mutations. Mutations, which are functions that take state and then update values in the state. The state itself, and then getter functions, which can compute values from the state. So for this talk, we're going to write tests for a Vuex store that's used in a web app that displays some cute pics. So it makes a request to an API and then stores the data returned from the API in a store and uses a getter to determine which items it should render. So there's pagination in the app. So we're just going to test one Vuex flow where we have a fetch items action that fetches data from the API and then commits a set items mutation with the data returned from the API. The set items mutation will update an items value in the state, and then we'll use a display items getter to return the items that should be rendered by the app. So there's three approaches for unit testing this store, and the first one might come as a surprise because the first approach is that you don't unit test. So unit tests take time to write and they take time to maintain, and you don't always save yourself time or get much payback from the time that you put into writing unit tests, especially if it's a personal project or some app that's not going to be maintained in the long term. And another thing is that often you can write end-to-end tests or integration tests that test parts of your store implicitly. So if the store is simple, it's probably more efficient for you to write just an end-to-end test that tests the store implicitly rather than writing specific unit tests for the store. But if you do want to write unit tests and get some of the benefits that I described earlier, the first approach where you actually write the unit tests is to test each of the store parts separately. So actions, mutations and getters are all just JavaScript functions, and you can write unit tests for each of these functions individually. So in our app we have a set items mutation that takes items in a payload object and then updates the state items value with the items. So if you wanted to test that, the mutation takes a state object and then updates a value. And that's what your unit test is going to do. You create a fake state object and then call the mutation and assert that calling the mutation with that state object updates the value in the state object. So there's the state object, we create some items, call the set items mutation with the items in payload object, and then assert that the items value is updated. So mutations are pretty simple to test. Firstly, you call the mutation with a state object and a payload object, and then assert that the state value is updated. Now, often mutations are quite simple, and it probably wouldn't make sense to write a unit test for a simple mutation, but you might have some filtering logic in there or extra logic that would benefit from a unit test. So the next part of the store you write tests for would be getters. And in the Vuex store that we're testing, there's a display items getter. So this display items getter uses the current page value from the state and the items that have been added to the state by the set items mutation, and then calculates the range of items that should be rendered. So this is just a simple JavaScript function that takes the state as a first argument and returns a value. And there's nothing really special about the unit test. You're just going to call it with a state object and assert that it returns the correct value. So here we're creating an array of items, an array of 42 items, and then creating a fake state object with the page set to 2. And then we'll just call the getter and assert that it returns the items from index 20 to 39. So the process of unit testing getters is that you call the getters with a state object. If your getter uses resolve getters, then you'd also call it with an object containing fake resolve getters, and then assert that the return value is correct. So the final parts of the store that you would test individually are actions. Actions are normally a little bit more complicated to write unit tests for because they're often asynchronous, and the reason that they're asynchronous is usually because they're making an HTTP request or something like that. So in our action we're calling a fetch data method which makes an HTTP request, and then with the data returned from the fetch data method we commit a set items mutation. So if we wanted to test this, we would want to stop the fetch data method that's called by the action from making an HTTP request. Because if you have HTTP requests in your unit tests will slow down a lot and they stop being reliable because network requests are unreliable. So to test this action we need a way of stopping fetch data from making an HTTP request. And the way that you can do that with jest is by using a jest mock function. So if you call jest mock with a relative path, what that does is when this file is evaluated by jest, jest hoists the jest mock call to the top of the file and runs that mock call before the rest of the file runs. And once mock has been called, any time jest requires a module, or requires that module, it will instead resolve with a mock file, a mocked version of that file, which has the same export signature, but all of the functions have been replaced with jest mock functions. And we can control the value of jest mock functions. So here we're going to set the fetch data API method to resolve with an items array, which means that when we call the action, rather than making an HTTP request, the fetch data method is just going to resolve with the mocked items array. So the part that we're actually testing in this action is that commit is called with the correct arguments. So to test that a function is called, you can use another jest mock function. So the jest fn factory function returns a mock function that records information about how it was called, and then we can use that mock function and assert whether it was called with the correct arguments or not. So next step is to await the fetch items action called with the fake commit mock function, and then assert that commit was called with the correct arguments. So actions, again, pretty simple to test, although you'll probably have to mock some file dependencies. But the process of testing them is that you call it with a mocked store context and an optional payload object, and then assert that the action commits the data, or if your action does something else, you'd want to assert that as well. But actions normally have side effects, so you test the side effect that it has. So that's an overview of how you test store parts separately. The benefit of testing store parts separately is that your tests are really fine-grained. So when one of the tests fails, it's easy to find out where the problem is, because the unit of code that you're testing is very small. But the problem of testing all the store parts separately is that your unit tests are brittle. It's difficult to refactor your store without breaking lots of tests. And the problem with unit tests in general, you can end up with the problem where all of your tests are passing, but your application is completely broken. So, so imagine if I changed the set items mutation name to set items data and updated the mutation test, I could run my unit tests and they would all pass. The actions test would pass because it's checking that I call commit with the set items mutation, but the app is actually broken. So the third approach is to test a store instance. So we just wrote tests for each of the parts separately, but when you're running an app, you combine all these parts together into a running store instance. So why don't we just test that? So when you test a store instance, what you do is create a store instance using the actions, mutations, state and getters, and then interact with it in the same way that you will in your application. So for our flow that we're testing, you dispatch a fetch items action, and then assert that the display items getter has updated to the correct value. So the steps to test a store instance: firstly, you need to install Vuex on the Vue constructor. Secondly, you create the store instance, and then the third step is to actually test it. So you dispatch the action and then assert that the getter value has been recomputed. So the first step sounds easy, right? We just install Vuex. No. The issue with installing plugins on the Vue base constructor is that once you install a plugin, any future tests that are using that Vue base constructor have Vuex installed. So this isn't too much of a problem for Vuex, but this is problematic with lots of other libraries, Vue plugins. So if we call Vue use from one of our tests, in the next test that creates a Vue instance, that's going to be using a polluted Vue base constructor, which can cause difficult to debug issues in your unit tests. So the solution is to use a local Vue constructor. And you can think of a local Vue constructor as the same as a Vue base constructor, except any changes, any plugins that you install on it aren't going to affect the Vue base constructor, and future tests can run without the polluted Vue base constructor. So the first step is to install Vuex on a local Vue constructor. You can create a local Vue constructor using the create local Vue method from Vue Test Utils. And once you have that local Vue constructor, you can just use it like the normal Vue constructor. So we just call use with the Vuex. So don't use plugin, use local Vue use plugin. So the second step is to create the instance. And normally in an app, when you're creating a Vuex instance, you would see some code like this. So you create a new Vuex store instance with new keyword. You pass in a configuration object with the state and the actions and the mutations for your store to use. But if you're creating multiple Vuex instances, multiple store instances in a test, you should extract that logic into its own function. So rather than inlining the store configuration object, we create a create store config function that returns a new object for you to create the store. And that would look like something like this. And the reason that it is a function is because you need each Vuex instance to have a fresh state object. So if you were just exporting the object itself, that would still cause problems between tests. So you have a function that returns a new state object each time you call it. So once that's all done, you can test the instance. And that's pretty simple. Like I said, you just interact with the store as you would in your application, and then assert that the store has updated the state or the getters in the way that you expect. So if we put that all together, it's quite a big test. So here we need to still mock the API method, the API module, because the action will still be calling the fetch data method, and then set fetch data to resolve with the items. I'm just going to extract that into a create items function. So the reason that there's items that we're setting item 0 is undefined is because I changed the mutation to filter the items, but then I forgot to change the mutation slide earlier, which actually filtered it. So pretend that our mutation is filtering the items to remove any undefined items. So then we just need to create the store by calling the create store config function, dispatch the fetch items method action, and then assert that the display items equals the correct items returned from the fetch data method. So the benefit of testing a store instance is that your tests are less specific. That's not a benefit, sorry, that's a negative. Your tests are less specific, so when a test fails, there's more code where the problem could be. It's more difficult to debug. But your tests aren't as brittle. You're free to refactor the parts of your store that aren't tested, for example, or aren't tested directly, like the mutation. And as long as the store implementation still returns the correct result, you're free to refactor without updating your tests. So some people might wonder whether testing a store instance is actually an integration test. So people like to split up tests into different test scripts. So you might have your unit tests, integration tests, end-to-end tests. I think the benefit of splitting your tests into different scripts is that different types of tests often have different requirements, or run at a different speed. So unit tests run very quickly, whereas end-to-end tests would need to start a server and take a lot longer to complete. So in that case, it makes sense to split up your unit tests and your end-to-end tests into different scripts, so that you can still run unit tests quickly without having to run end-to-end tests and start a server. But in this case, your tests are going to run at pretty much the same speed. So I don't think that there's a benefit necessarily of splitting them up into integration tests. I think the benefit of splitting tests into integration tests would come if your integration tests were significantly slower and were doing something like making an HTTP request. So I'd say keep this in your unit test script. And yeah, I guess you're probably wondering which approach should you use. It depends, really. So it depends on the size of your project. It depends how many people will be working on it, how much development or iteration you're going to be doing on the code. But for me personally, if I'm working on a small project, like maybe a browser extension, and it's just going to be me working on it, then I probably wouldn't write any unit tests. I might write an end-to-end test. If the app got a bit larger, then I would start by testing the store instance, because you get a lot more coverage for less code, and it's easier to refactor your store without updating unit tests. But when an application gets really large, it can be difficult to test each of the Vuex flows by testing the store instance directly. So on a larger team, on a large app that's going to be long-lived, I would probably write unit tests for each of the parts separately. So yeah, thanks guys. That was all I had to say about unit testing of Vuex store.